shaping a more responsible future with tech, the relevance of human-centric technologies, and the societal impact of digital twins innovation. So today I'll be the speaker together with my colleague Eva. But before going into our topic, which is digital twin, I would like to share with you a few things. Oops, the slide. So the webinar will be recorded. So in case you would like to have a look or if you miss anything, we will put the link on our website. Please switch off the microphones if you're not a speaker to avoid any noise in the background. And if you have any questions, please put them directly in the chat and we will answer them during the interactive discussion. And one last point, if you have any questions after the webinar, you can write to us to the email address that it's on the bottom of the slides, which you can see on this slide. So, I cannot go up. So the agenda of today's, so we will start with a short presentation of the forging project. Then we will move to the presentations of each speaker. So we will have 3 speakers that will share good practices and lessons learned in the application of digital twins innovations. Then we will move to the interactive discussion and we will end our webinar with a short wrap-up and upcoming forging activities. So here, I'm not going to spend a lot of time on this slide because my colleague Eva will introduce them later, but it's just to show you the speakers that will provide a short presentation later on. So now we can move to the forging presentation. So what is forging? Forging, my slides, sorry. So forging is a project founded by the European Commission, which started in 2022 and is ending this year. So we have still a few months to go before the end of the project. And in forging, we aim to set up a forum with different experts, different background, academia, industry, scientists, society, in order to ensure that, first of all, they are included in the discussion because they're also users of these technologies, and also, as I put on my screen, to accelerate the uptake of emerging technologies. This project is implemented by 6 European expert organizations. So we have INL in Portugal, which is the coordinator of this project. Then we have GAC, so us in France, 2 Italian organizations, APRE and STAM, then VTT in Finland, and I2CAT in Spain. We all know that emerging technologies are not part of our everyday life, and technological advancements have a huge potential to overcome any critical industrial and societal challenges while accelerating also the green and digital transition. And in forging, we are looking into 6 technological frameworks, which you can see on the screen. So starting from the top left, so we have the human-machine interaction. We have the bio-inspired and smart materials. We had a webinar a few weeks ago on this topic. Then we have the digital twins and simulation, which is the topic of today. Cybersecurity, for which we had a webinar in December. Artificial intelligence was the first topic of our webinar series. We had this webinar in November, and also the energy efficiency topic. So moving to to the next slide. So what concretely is our approach in forging? So in forging, we are supporting, as I said earlier, the uptake of emerging technologies by academia and industry. We try to build the bridge between these 2 worlds. So we try to connect the research and business world because we all know that there is a kind of gap between them, and because both of them are key drivers of innovation. We are looking into the 6 technological frameworks, as I said earlier, but we are going a bit further. We aim to transfer ideas, concepts to help industry, to find their way through issues related to the deployment of use cases, so the concrete application of technological pathways. And our methodology is based on the value-sensitive innovation journey, which refers to the approach that when you develop a technology and use this technology, you're not only looking at the technological aspect, but also the human and environmental aspects. All right. So this was my last slide. And just one last point. What makes forging relevant today is that it aligns with the principle of the Industry 5.0. So it focuses on the role of humans and the collaboration between human and the technologies. So that was my last slide. Now I'll give the floor to Eva, who will introduce each speaker and will moderate the interactive discussion. Eva, the floor is yours.
Thank you very much, Charlotte. So great. Now I'm inviting our different speakers, starting with you, Björn. And once you set up your slides, please, I would like to introduce to the audience who we have with us. So very happy to have Björn Norman Eriksson, who is the CEO of Moicon. And Moicon is a company based in Norway, which is specialized in digital twin technology for manufacturing, industrial planning, and operational use. For example, Moicon recently collaborated with a local company to create a digital twins model for the new facility, providing them virtual layouts and configurations, helping them in the overall process. Björn has a strong background in technology and innovation, and he focuses on leveraging game-based solutions to optimize factory operations and enhance sustainability. Björn, are you able to set up your slides? Is that working?
Yep.
Right. So then, very welcome. The floor is yours.
Thank you. My name is Björn Norman Eriksson. I'm the CEO and co-founder of Moicon Digital Twin. We're a company based in Norway. We're a software as a service company, and we specialize in digital twin technology for manufacturing. Our business model is the software as a service. So we have a licensing software, but we also do a lot of projecting by digitizing factories. And our team is quite special. It's mostly built up of 3D visualization experts from the gaming industry. And we also are a certified partner with Autodesk. We utilize Autodesk platform services in our tech. And we also are a partner with Manufacturing Technology Norwegian Catapult Center here in Norway. That means that we're able to test our software on many different manufacturers here in Norway. And also we became a Autodesk sustainability tech partner this summer. And Moicon's mission is to provide manufacturers with valuable insight, sustainable operations, increase performance, and decrease costs by communicating more efficient. And our goal is to be the friendliest digital twin available for manufacturing. So I don't know how many gamers are listening here today, but I don't know how many courses you took to play Sims or Counter-Strike or anything. So we are very strongly influenced by gaming and using intuitive solutions taken from the gaming industry. What's a digital twin? Digital twin is, if you ask 10 different people, I'm sure you get at least 40 different answers. Because a digital twin is like a buzzword, but my representation of a digital twin is a digital replica of something physical. So in our case, we usually concentrate on factories, and we started out by aiming to small to medium-sized enterprises and create a digital twin solution for them. But we see also that we are now talking to quite big factories because our solution is so simple to use. What are our competitors? Well, most of our competitors is 2D based, like Excel and 2D drawings of factories. And yeah, why does visual communication matter? Our vision trumps all other senses in our brain. And a lot of us engineers, I can prove it by utilizing Lego. I think most of you have played with it sometime, and you can have a perfect description in the book on how to build your Lego with the best text, but your brain still has to interpret the letters, interpret the words, interpret the sentences, and then your brain have to hallucinate and use your imagination to how to build up the Lego model. And if you play with Lego, there's no text in a Lego description. So your brain has to interpret a lot less if you can get it visually. So by using visualization, we communicate a lot more efficient. I also reference the book here, Brain Rules, because they've done research. If you read something, you remember about 10% of what you've read in the next 3 days. But if you have a image to support what you're reading, you remember 65%. And that percentage increases when you get colors and animation and 3D visualization. It increases, so you communicate a lot more efficiently. A lot more things can be misinterpreted through using 3D visualization. So what do? We collect the data from the factories. We sort the data for the factories. We present it visually by creating dashboards and stuff like that. But then we connect the data into the digital twin. We connect the data into the 3D visualization. But then also we add for factories data analysis for factories, and then we can explain the story by using our digital twin solution to tell the whole story in the 3D environment. And that's where digital twin can help by planning, for instance. Because we have put our technology on top of Autodesk Platform Services, we support about 80 different formats. So if you have a technical drawing from your architect or your contractor, we can put that drawing into Moicon, and you can use it for simulations and tools. And if you've bought a new machine, you can just ask the salesman to get the CAD drawing of that machine or robot, and you can just drag and drop directly into Moicon. Moicon is web-based, so it's accessed through a browser, no installation needed on your computer. So everything is accessed through your browser. And then by adding all into Moicon, you can also add parameters to your 3D model. So you can add data to the 3D model. So you can, for instance, you can do process analysis by figuring out where are your bottlenecks in your factory, and you can also find out how you can make your factory more efficient. And for instance, you can think that you are efficient, but when you start to put numbers to it, then you get real data. And then we can, for instance, you can find out if you just have to change your layout, or if you have to buy a new, more efficient robot, or put more people into your factory. And everything can be exported into Excel, so you can put numbers into it. On that way, you can put in return of investment on your economic purchase. And also, we can collect data from the factory. So, for instance, you have sensors like these. This is a waste management sensor. You can visualize how is the containers filling up, or what are the status of your factory right now. So a lot of factories, they want to know the OEE, operational equipment efficiency. How much of the time is your expensive robot being used? So that's something we can calculate on and help the factory visualize. And also, we just started the project with electronics factory. That there we are putting in sensors in the factory that we can visualize where are the climate gases being emitted. So, for instance, this electronic manufacturers, the biggest climate gas producing element is electricity. So we put in sensors on every machine. So then they can visualize in their digital twin where are the electricity being used. So where are, for instance, they have a soldering oven that's very high demanding on energy. Then everybody in the factory knows that, okay, this is where the soldering oven that uses all this electricity is located. So, like I said, communicating a lot more efficiently. And from World Economic Forum, 22% of all climate gases, or CO2 at least, is coming from manufacturing. So we have a big responsibility to take on this task. And that's what we're working on right now. So we are looking into, or we are well on the way to look to generate a ISO 14067 report for our clients. That means how much climate gases are being emitted during the production. So, like I said, we're now monitoring how much power, how much gas consumption, how much chemicals are being used in each process. And then we take, for instance, this electronics provider, they have circuit boards that go into different processes based on what features is going to be added to this circuit board. So each circuit board has different processes it goes through. And then we can calculate for each product how much climate gases are being emitted for this specific product. And also we are now putting ChatGPT into our solution, or OpenAI. So we're putting decision support into our solution. I'll talk a bit more about that on the next slide. And also we're utilizing a lot more powerful rendering engine for our customers. So, and how will that affect the customers? Yes, you can use a lot simpler computer to rendering the 3D. So a lot of technology today, they use either the GPU or the CPU of the computer, but we're looking into technology to utilize the whole computer in a much better way. And now we have a pilot with Hopper Electronics, and now we're also looking into more research, because we met some big challenges in our project. And we have a project now with Autodesk and the local university here, Norwegian University of Science and Technology, because we have seen that a lot of the data needed to generate these reports are missing. A lot of the data from life cycle inventory, like from how do you produce the raw material and what do you do with the raw material when you throw it away, a lot of the data is missing. And we can buy the data, but a lot of the data is research based, and it's not possible to research on all different materials, or it will be very expensive. So we need to find a way for the manufacturers to share the data in a much more efficient way. So as an example, we have aluminium. I just brought it up, that aluminium produced in Norway is a lot more expensive to buy than the aluminium from China, for instance. But because it's produced locally, and it's also produced with a clean energy from water power, it produces a lot more less CO2. So 1 kilo of aluminium in Norway produces 7 tons of, or it's 1 kilo of aluminium is 7 kilos, sorry, of CO2. But if you buy the same aluminium from China, it's 20 kilos of CO2 per kilo of aluminium. So we're looking into adding the decision support into our solution, but also getting more insights and also sharing the data much more efficiently. So like I said, there are companies, big companies that can sell you the data, lifecycle info data, but it's mostly research based. So you get great databases like EcoInvent and other databases that you can get the data from the raw material. But for instance, our customer, Hapro Electronics, they buy circuit boards from China, but they don't get the data with the circuit board. And it's very cumbersome to get that. So we need to generate a way to share the data and verify the data much more efficiently. And that's what our product or our next project is how to share the data and make it beneficial for the providers to share the data with you. So we're looking into how they can earn money by being more transparent, and also we want to decentralize the data. So we're actually looking into using blockchain to store the data from the manufacturing. So and I have short time, but I can show you just live. I know it's a bit laggy from your end. That's Teams, not Moicons. So here you have a factory with a cloud, and we connected the sensor into it. So this cloud is connected to this sensor I have here, and it's measuring particles in the air. So I can measure how much pollution is in the air. So this is some magical spray, also called hairspray. And then you'll see it will gather data and show the data digitally in the twin, so it will change colors.
John, 1 more minute, please. Yeah.
Yeah. Yeah, it should change colors, but yeah, it's stuck. Okay. Yeah. So that was my presentation, and thank you for the time.
Great. Thank you very much, Bjorn. Very insightful. I like the hairspray. So great. Now I would like to invite Lorenzo Forte, who is the regional sales manager for EMEA Twincity, which is a Germany-based startup. And Lorenzo, once you set up your slides, I would like to shortly introduce you and your company. So Twincity has actually developed a virtual tool which is using a unique visual intelligence technology, which improves the way how to inspect and maintain physical infrastructure. It is driven by photorealistic 3D models and AI-assisted damage analysis in a secure web-based platform. Lorenzo Forte is a seasoned professional with over 8 years of experience in the geospatial industry, specializing in unmanned aerial systems and SaaS solutions. Lorenzo has also helped businesses integrate innovative geospatial solutions for efficient asset management and sustainable operations. Lorenzo, we're glad to have you with us. Please, the floor is yours.
Thank you very much, Eva. Hi, everyone. So yeah, Lorenzo Forte from Twincity. I'm very excited to be here today and have a chance to discuss with you how digital inspections are helping professionals and communities globally. So as just briefly mentioned in the introduction, Twincity is a German startup. It's focused on AI-driven infrastructure inspection solutions. So our goal is to offer inspection teams a platform that allows them to better manage and analyze the data and consequently make better decisions, which will improve the safety and sustainability of their physical assets. So our vision is to be an integral part of a world where infrastructure assets are managed efficiently with minimal human intervention. We'll see in a second how that will happen on our platform, but basically contextualizing the geovisual data that's collected by drones and robotics that then can be easily shared and used to basically make meaningful decisions. So a challenge that we have nowadays is a global aging infrastructure. So more and more in recent years, unfortunately, we have seen unfortunate events such as the collapse of a bridge We see in the image there an instance of what happened in Germany last year in Dresden, but also comes to mind an example in Genoa in Italy. And so more than ever is a solution where we can have a cost-effective inspection tool and process that prevents catastrophic failures is needed. So when we're looking at the inspection process, we know that technologies such as drones have been transforming the way that people are collecting data for many years. So these are tools that many people are familiar with, they heard of, and they either used by teams on site where they can operate these machines to collect data in an automated way, or more recently we even see drone in a box solutions where we have drones that can operate autonomously. So there is no need even for teams to be on site. They can just control from operational rooms. And so this data can be collected efficiently, faster. It removes people and teams from dangerous environments. But what we see is that there is an additional challenge or problem that's brought up by this type of data collection, and that's the data handling. So during a traditional inspection, a drone might collect up to 10,000 or in excess of 10,000 images, high resolution images. So we see that there is a raw data that's quite heavy. It's usually processed on site on a laptop, and then there's a specific software is required to unpack that data and then to be visualized. So we can see a very time-consuming process where the data cannot be accessed by everyone, and you need to consult with a local person that has the expertise to give access to that data. So there is also a lack of scalability, when we're looking at analyzing inspection data, and in this specific case. And so that's where we come into the picture with our platform, TwinSpect, which is focused on digital inspections. So we really want to offer a platform where we have a 3D representation of the asset and a very easy way to analyze it and share it to generate meaningful insights. So how do we do that? If we look at the workflow that we have, basically there is a data acquisition that's done by the drones, as we mentioned previously, and then the data is uploaded in the form of a 3D model onto our platform, where with various tools we'll touch on in a second, we have means to carry out inspection, and also through the powerful AI models, which are allowing us to do automated detection of defects. And then collaboration is key. Obviously here, and it's a web-based platform. So as long as the user has an internet connection, a web browser, you'll be able to access the data. Here we have a sneak peek at our user interface, very streamlined. As you can see, no need to be an expert, very user-friendly. As long as you know how to use a mouse, you'll be able to navigate this platform with confidence within a few minutes. You can see that we display the 3D model of the assets on the platform together with the high resolution images. And so you'll be able to click on a certain point. You'll have a close-up view over the 3D model, as well as having all the relevant images that are capturing the specific point or defect that you selected. And in here, then you have the ability to create some annotations to record information about certain anomalies, features, or defect. All of this is in support of basically facilitating visual remote inspections of these assets. There are three main pillars that we're looking at here. So basically the visualization of the data, it's key because we have a full overview of the asset. People can interact with the 3D model and the images. They can review it as many times as needed. Teams potentially don't need to go back on site into a dangerous environment. And then, of course, being web-based means that the collaboration is very easy. People can be invited into the platform effectively. They can contribute with their insights and review the available information. All of this supports a very effective inspection process because we have obviously the easy to view assets, multiple stakeholders being able to provide the input, and also tools such as the AI models that are supporting that process. So if we look at some of our specific features here, I mentioned before annotations. When we looked at the user interface overview, basically is the ability, digging a little bit deeper, for you to label or draw a box around, in this case, a defect, but it could be any feature that you want to highlight, and then record some information about it in a template. We call annotation template, where you can provide a name, a description, damage type, and recommended actions, such as needs to be repaired or to be kept under observation, as well as a severity level. This annotation template can also be customized, so we could change this to suit any specific needs. And you are able to group these annotations into folders and organize them by defect type, and also manage what type of information is provided into your report, for example. So what we can do once the inspection is conducted, we can generate a PDF report via our platform. As you can see, you'll have a full list of all the annotation in here, and each page will have the information that they were included in the annotation presented here on the page with the 3D image, the still image, and then a link to the 3D model onto the platform. So people are able to contextualize the information on a single page, but also go back to the platform, onto the model, and review it over the full 3D model of the asset. What we have as well here are our AI models here. So there is a significant benefit of using this automated detection, as if we compare it to traditional methods, of inspection, where people might have to go through thousands of images manually. Here we have the benefit of having these models flagging these defects for us. So we basically load up a model as a project. We run the AI solution, and all the specific defects, for example, could be cracks, are flagged onto the 3D model. And because we have the 3D model and the still images, we can also do some image clustering for the identification of defects. So what it means that once a defect is detected, and we have a label and annotation connected to it, this label is automatically flagged and recognized by all the images containing the specific defect. This is a tremendous advantage because obviously, one defect counts as one and is identified right away in all the relevant images. Whether compared to manual inspections, we see that potentially you could double count some defects or even miss them, because you might have many images that are capturing the same feature. When we're looking at AI models, we can also develop custom AI. So if there are any specific defects or anomalies that a team wants to detect but are not available in our models, then we can make those. We can create one specifically for them. And these are what we call our community AI models. So what it means that we have a feedback process that's available. And so basically allows teams to provide feedback on the accuracy of the detection, and that's taken into account to keep improving the model over time. And obviously, the more is used, the more as well improves. So, in conclusion, what we see is that the adoption of digital inspections, it's really enabling organizations to scale their operation and increase their efficiency. So as we've seen, there is a faster result compared to traditional inspection methods. We see some current users that have seen the inspection workflow going from days to hours. So that's thanks to the 3D visualizations with the high resolution images that we have there, together with the help of the AI automated detection. Also, a much more reliable inspection outcome is provided through the AI models that are able to flag those defects consistently over time. And the results is on significant increase in the safety of the operation. So that's for the teams, that was mentioned before, that they are removed from dangerous environments, and also for the infrastructure itself. So focusing on preventing those catastrophic failures that we mentioned earlier. The impact on the organizations in terms of cost savings and efficiency is evident. And also we see a positive impact to the communities that can then eventually rely on sustainable and reliable infrastructure. That's it from our side, and looking forward to the question time.
Great, thank you very much, Lorenzo. Very interesting. You can see these so diverse applications. So I would like now to invite Théo Francois, who is the CTO from Vectual, a company based in France. And while Silvio, you set up your slides, I would shortly introduce you. This is a company actually with a strong expertise in digital visualization and urban planning, because Vectual transforms complex projects into immersive and interactive experiences thanks to 3D models of urban environments. These innovative 3D and digital twin solutions are helping stakeholders to better understand and engage with their environment and take decisions related to urban planning. It shares its insights on the intersection of technology, visualization, and strategic decision-making in shaping the future of urban and industrial landscapes. Hello, we are delighted to have you with us. Please, the floor is yours.
Okay, so hello everybody. Today we'll introduce you what we do in Vectual, mainly in France, well, in other border country, and especially as a comparison of my two colleagues that just intervened, we work at the city, more at the city scale. So we work on like big city digital twin, and today I will show you how city digital twin can be used by municipalities to be able to look at what is going now in real time, but we are us more specialized on how to plan the future. So I don't know why my presentation is not 2 seconds. I'll be back already. Okay, so where are we? So we are a 20 years old company. We are around 20 people, and so our job is to resign from the territory and its project. So what we do is we do modelize the city in 3D, and then by planes, and then we do add some project and some let's say future planning to be able to bring in data and vision to the municipalities. So the fact is, we bring data and vision to the municipalities and to the territories. We do it also to empowering communities to be able for city planner or citizen to conceive urban project. And we do it at scale because we can do it on like very small territory. And our biggest client right now is, for example, the Société du Grand Paris, which is the biggest urban transportation project within Europe because it's building like a 72 railway station, and it's concerned, and we modelize like more than 2 million of building to be able to have that digital twins. So like I say, some images are better than words, so I did prepare more like videos to be able to show you all the examples and all the way cities can use a digital twin. Oh yes, so that's us. So we can, so the point for us of a digital twin, the first is to make enlightened decision. When I say enlightened decision, it is mainly there's the first, it is for the technical department to be able, and they do not need any 3D to be able to conceive the future, or just a little piece, and they don't have to be magical or very good looking. But when you explain something to a decision maker, he has to see it in 3D, and he has to see it the right way, because he don't understand anything about how the stuff are made. So the first thing it is, for example, this is Paris, and so this is 1/4 of Paris that we had in 3D modelization. And the thing it is how to put trees in the streets, and how we intervene, how we can create like parks and stuff like that. Sorry. Attends, 2 seconds. I don't know why, but it's always switching. Yeah, that's it. What we can do also, it is to be able to choose on several urban projects, to be able, same thing, to have a better city. Other use, it will be able to see all the networks that you have within the city, within the ground. So here we build a digital twin of real city with all the transportation, energy, water, electricity, to be able for the municipalities to say, okay, right now, if we have something to do in the technical way, if we have any troubles, we can look at the digital twin and we can plan what will be the energy that will be consumed, or we'll do that kind of urban work, how we can manage and change it. Same thing. Here it is for to simulate disaster. So here it was even virtual reality, you know, that people can be like 20 on the same scene, and they can all see what can be and what can be the plan. Something like that is transportation. This is the same for mobility. What will be planned, or what can they react when the future will be that way? On the same thing, we can, you know, build some explanation of how the city will change. We also simulate urban lightning. Same thing, to be able to, for example, this is a park, and something very important for city is security. And here, the most important stuff when you build a big park is how the city will be lightened to have, like, for security reason. Then here, this is another example with we call that beam sim in French. Sometimes I don't have the stuff in English, but whatsoever. This is the technical part of the city. It means in France right now, most of the city are not ready to do it. But what we do it is that we propose them to have all the technical building accessible through the city platform. So then when they build something, they will know what will be in it and where will be the last, let's say, technical model available. It will be within the platform. So I show you a lot of stuff there. So there is well, we did it for, I don't know if you know the Coas company, but it's a worldwide company, and we did it for all worldwide platform. And then what we do also, it is what we put that on the web to show to the people directly. So here you are in Paris La Défense. You can see it as you go to the website. And the point of this, it is to show the future to people, to say, okay, my city will look that way on the future. So we do immersive realization. So to build that, we cannot apply and we cannot rely on just one technology. That is very important, because we have several platforms with several technology to be able to reach and to be used by several people. For us, a technical point of view is not the same that a citizen or a decision maker. So for them, each one should have a different platform, different access, a different vision to be able to see just the information they need, basically. So we have like Unity-based solution directly using video games engine and real-time sensor. We have VR solution. We have web-based solution. But the main stuff, it is linked to the same database. And then those are just outputs that we can fit and that people can use depending of the needs. And then, yes, I put that a bit for for the R&D department, but then I will have some more slide on it later. But the main point, it is all that we do right now, all modelization and all the stuff that we do on the web. We saw that with AI, it is something that it's evolving a lot. And this is something that we totally have into our mind, and either to be able to look at the data or to make it or to be able to forecast it, those will be very impactful. For how we address our social challenge, because for us, if you have a transparent urban planning, people will help to build the city. Second thing, by giving to the decision makers the good information, we know that they will have the good decision for the city to be able to evolve. And then how it's linked to sustainability and resilience. It's really linked because in fact, if you want to have some changes and if you want to be able to change the city, you have to score and to evaluate the impact of each solution and how the city will evolve. In France, we have something that's called the whatever. It is the same. It is right now. The city don't have the right to build on more lands that are already built. So how you do that if you don't have any kind of simulation tools? So what we do is that right now we help them with predictive urban development based on score evolution. We can help them in real-time urban insight. It means that with sensor right now we can connect even this urban ecosystem, BIM, GIS, and IoT to our platform to be able to give the right information at the right moment to the right decision maker. Then also, we really think that building our solution without any big cloud, without any big consumption, to use AI in, let's say, very small way, but in good way, is also something to reduce the ecological footprints on all the project and something that is really required into all urban transformation right now. And to be able to end my presentation, we also driving societal change with what we do, because by involving people and in the way the city is built, and right now we work with all the French big city, you also have some project and a collaborative approach. That is something that people really want, and this is something also on which the city evolve well. And the last stuff, it is what we do also, it is the innovative R&D. I just put a small board of our next project. And our next project, it is to be able to integrate directly in our platform AI to help building future city with parametric city modelization, respecting the legal part, because the legal part in France to build something really important, and also to be able to score each plan evolution of the city on several metrics, like air quality, numbers of trees, on CO2 consumption and everything, to be able to choose the least ecological, sustainable change possible. So that's the reason why we think that we are contributing to shaping a more inclusive and sustainable urban future with our way we do digital twins. That's it for me. Now I speak.
Great, thank you so much, Taylor. Very, very informative. So we're now moving to our interactive discussion session, and I'm inviting, of course, all the participants again to ask additional questions, ideally through the chat, because we're quite a lot here today. But I'm trying to resume already the questions we had, because some were already answered in the chat. But I see that a lot of data, these questions relate to data. So trying to summarize a little bit, and these questions are, this question especially is for all the three of you, please. So how do you get the data? How do you store it? And how do you secure it? Maybe we start with you, Telo, and then we
Yes.
move to the others.
Yes. Well, for the data is kind of a bit different on on how I saw those answers, because we don't work like in industrial close way. It's not something secret. We work with a lot of open data, in fact, or data that are given us by the cities that are our customer. Because basically we work, we have software, but we work on software as a service, but there is like a big relationship on which we use their data. So most of the time they are using data directly with, for example, with open source platform or data management platform or data lake. So we took directly the information from that data lake. So there is like a secure transfer, but we don't use any blockchain or stuff like that, because most of the time on what we do, we don't deal with, let's say, so much secure data that people want to look at. Let's say that.
Okay, may just add on specifically for you, there was a question about is your digital twin linked to the real physical world, and do you manage live data from the physical world? Maybe you can just add on.
It's not, to be fair, it's not our specialty. It's not. We have some project on which we do that, but our main project are not linked to the reality because, well, it is what we say at the beginning of the presentation. I think that it's Bjorn who saw that, and I'm very agree with that. Like, we don't do real digital twin in the sense that the digital twin is not even 3D based. The digital twin for me, and the common argument should be, let's say, the real-time situation on an object, on a city, on a plane, in railway. So this is something that is relinked by sensor. It's more the, let's say, a super control room of the city. We don't do that because let's say that for most of the time you don't need 3D to do that. And we are specialized in 3D. So what we are specialized to, but as I say, we have some project on it. We do have a real sensor in it, like, I don't know, counting bikes or some energy stuff or whatever. But the main stuff that we do it is because we work on a very big scales. We do some stuff. Our specialty is to do also lovely stuff for people to see it. It's not just to put and add show technical data.
Okay, great. Thank you, Taylor. So yeah, maybe we move to Bjorn. How do you get your data? How do you store it? How do you secure it? Maybe from your point of view.
Yeah, I can start with the security part. Our biggest customer is the defense manufacturers. They produce rockets and ammunition, and security is very, very important for us. So we have all our data stored in international known big cloud centers, and we also are encrypting it, and also we have two-factor logins. And it's up to data, it's up to the customer. As long as you have an API, we can collect the data and give that data a property in that 3D visualization tool. So we can have, for instance, data coming from your robot. If you have like automated guided vehicles on your floor, then we can collect X, Y, and rotation. So we can show real time in your digital twin where are the robots at any given time. We can take data from sensors in your factory, for instance, temperature or humidity, and we can put it into context while having cloud changing colors. Or as I said, we have electricity consumption, and we can add parameters to the assets or the 3D models. For instance, have the machine changing colors based on how much electricity is being used at any given time. So it's up to the customer on what KPIs is important to have visualized in the 3D model. So it's very dynamic and agile. So we can just add parameters into it, and it's up to the customer how to use the data.
Okay, and I think you mentioned also that you are investigating on blockchain as an option for data sharing, right?
Yeah, so like I said, it's climate data and how much data or how much climate gases are being emitted during the production, we see that we need to create a network and how to share that data, because it needs to be more transparent, more open, easily accessible. So it's the other way of being more secure. We need to be open on how things are being produced and how much climate gases are being emitted. And using blockchain is a very high security way of storing data, because then we can put verified data into a blockchain, and every block in the chain has some history of the other blocks. So it's if you change the data or manipulate the data, you will tell at once. So it's a very secure way and possible to change. So we're looking into using blockchain. It's this year we're going to use a lot of research on how we can be more open with the data sharing.
Okay, thank you very much. Lorenzo, from your point of view, how do you get the data? How do you store it? How do you secure it?
Yes. So from our side, there are like a couple of ways, but basically the data is provided by our users. So it could either be organizations providing inspection services or asset owners that are inspecting their own infrastructure. So they could upload the data via our platform. So there are guidelines on how you can upload all the required files, or this with some integration work could be pulled directly from their management system, depending on the API available. But in terms of storage, it's all cloud-based. So we're using Amazon Web Services, and we do have option of data isolation, so having the data stored in a separate server for our customers. And so that's the options that we have at the moment in terms of managing the data. Of course, with AWS, you get the security standards that comes with it in terms of data protection. Twin City as a company also achieved a HISO certification in this regard too, on how we're handling the data for our customers.
Okay, yeah, thank you very much. There was also an additional question. If there is a specific technical environment that's required to use the data then?
A specific technical environment to use
Yes.
the data? It's just to visualize it? No, not really. I mean, like the data is basically visualized and analyzed on our platform. So the only thing that's needed is an internet connection, a web browser, and the ability for our users to upload the data. But that's it. There's nothing specific. But then obviously it depends on the inspection requirements. So if you're looking about data quality, then we do have some guidelines depending on what they want to identify and detect. But that's more related to data collection and the quality of it. Yeah. Okay.
Thank you very much. So I hope I have answered the question from the chat. There's just one that I saw just popping up, which is how do you see in future using human digital twinning, for example, modeling what people do in your models? This came up during your presentation, Telo. I'm not sure if it is only related to that one or if all the others would like to answer also. But please, Telo, if you can give it a start, yeah.
Alors, two stuff with that. The first, it is, yes, it is something that, same thing, first on what we do, basically to use the 3D to do that is not something I don't think right now have a really huge impact on the vision and on the data, on the stuff you can get. But right now we are on another European project about mobility, and we do such R&D on it to be able to, with mobility and with people mobility, to see with the multimodal mobility how we can represent that in 3D in a way that people will be in an immersive. Let's say what we do, it is very immersive because it is 3D and good, let's say, good looking 3D. So indeed, we think that we can arrive to achieve something with the to modelize the people and use the feeling we have on if we are granted with people, for example, to be able even to make decision, because you make decision also most of the time to the on scientific ways. but sometimes also you need to have some feedback, feelings, and the sense the way you have, like when you are on a place and it seems too crowded, than when you are on the, let's say, one scale, the scale of a person, and you see some stuff and you feel some stuff that you can only see when you are in an immersive scene. And this is something that we want to be able to use, and also to be able to have people at the same way to be able to get those feelings. I'm not sure I'm very clear, but in terms of R&D perspective, in terms of that matter, it is the way we are looking at.
Okay, yeah, thank you. Anything you would like to add, Lorenzo?
Yeah, from my side is the fact that we consider ourselves pretty much at a starting point. I mean, our solution will evolve significantly in the future. Obviously, wanting to integrate then the ability to have like a real-time feedback from infrastructure itself, and be able to leverage like autonomous data collection means such as like drone in a box. So that will evolve in that direction. For us to then offer more live data to asset owners and our customers, basically. And the results, the positive impact of that would be for mobility is the fact that obviously there could be the prevention of failures in the infrastructure system, but also the predictive maintenance and perhaps like development of improvement of those assets.
Okay, thank you. And Björn, is modeling what people do something you look into?
Yes, because we are already gathering data and we already have a simulation tool into our solution. We have a process simulation, and we use the data from the factory to make the simulation even better with real-time data. So the future is more data available. Like I said, the challenge is to share data across factories, because a lot of factories they are hesitant to share the data because they think they're sharing technology secrets and stuff like that. But that we don't know. That's something we need to research a lot more, how we can share the data more freely, and also for us to generate 3D is something also we're looking into the future to, for instance, use smartphones to scan and put into digital twinning. The technology is evolving a lot, so we get more and more data, and the data is more and more easily implemented into a digital twin.
Okay, yeah, thank you very much. I would like to move also to questions which relate a bit to our focus in FORDINC, which is about responsible innovation. Having a development innovation that is taking account of the humans and of the society, the impact it can have on society, and ideally also having positive impact on the environment. So maybe starting with a question, how do you ensure your product or your solution is meeting the needs of society? Björn, would you like to start on that?
Yeah, I answered also in the chat. We are very close to our customers, so I want the developers to be involved with the end user, and we see we can take responsibility to sustainability, but also like health and safety. So we have one customer, for instance, that have identified 30 different fire scenarios in their factory. But by using a digital twin, they can go through all of them digitally, and then they can train physically on 2 of them. That means that this will have a big impact on safety for a lot of workers, and that's how a digital twin can be beneficial. It makes you so much more efficient on communicating than just by using 2D plans or just reading about it. So it has a big impact on humanity.
Okay, great. Taylor, what is your view on that? How do you ensure that?
But I think I already answered that in my presentation, that we work a lot with end user, and the fact that we have some end user interface that are all to the point is to make easy the access to the information. For me, it's very linked to the fact that yes, it's more or less a tailor-made solution for the people. So yeah.
Okay, thank you. And Lorenzo.
Yes, for us is a heavy focus on infrastructure, and so we want to make sure that the infrastructure doesn't fail, sustainable, so it can be used for a long span. And avoiding those failures or issues also means that there's potential less environmental impact. I mean, if you look at some of the collapses of bridges, for example, over the river, that's caused a lot of trouble to the economy also of all the countries that were relying on that resource. And also the environment itself in there. So this is definitely something that that we're focused on.
Okay, thank you. So I was wondering, well, you've all mentioned the human aspect, a bit also the environmental aspect. I was wondering if we speak about responsible innovation in emerging technologies, such as in digital twins. Do you think this is adding value? Do you think, especially for Europe, it's adding value to have an access on responsible innovation?
What do you mean? Sorry, I didn't get that.
So when we speak about responsible innovation, we mean innovation that is taking account of the impact it's having on the society and not being harmful for environment.
Yeah.
So when we look into the emerging technologies and especially the digital twins here, do you think this is adding value to look into these two aspects, society and environment?
I think they have to be eco-based when they are building such. You have that. You do need to have that in mind when you build your solution, because in fact you use like big servers to like AI solutions that are consuming a lot of energy. If you're doing your technical solution, you consume more energy than the CD can save later using your solution. I mean, I think you are missing some points. So yes, to use a lot of like computing calculation, to use like a lot of cloud, for us it is something that we take into account when we build our services.
Björn, what about you? What's your opinion on that? The responsible innovation, is it an added value for Europe?
Yeah, it's like you said, it's also innovation. Also the biggest innovation with digital twin, I think I speak from all of us, is that everybody understands the data, and that will be so much more efficient. And then, for instance, reading a book about environmental impact. So you can see and tell the story with digital twin, and that's how our innovation can benefit from using digital twin can show everybody where are the energy being consumed, where are the climate gases being produced, and that's how our innovation can make a big impact.
Okay, thank you very much. And Lorenzo.
Yeah, I can echo what Björn just said. For us, that is we're very focused on making sure that the innovation is following the demand of our users. So how the inspections carry out, where the inefficiencies are, where the dangerous environments and bottlenecks are, to make sure that people, first of all, are not operating in a dangerous environment, and second, they can identify like critical issues in a fast and then act on it. So this has a benefit on safety of the workers, as well as the economic aspect of the company, but of course also on the communities that they don't have to deal with the aftermath of for example, failures in I talked about infrastructure, but we're also doing a lot of inspections into industrial estates, so a lot of tank inspections. So it could also be potential failures that cause like a release in environments of chemicals. So yeah.
Okay. So is the human and environmental aspects an asset to promote your company? Do you use that when you do the marketing of your company?
I go myself first, yeah?
Yes, please. Yeah.
Okay. So yes, we do mention that. So there is importance again in in how the automated inspections are helping in humans to complete those tasks. So it's something that we see, as I mentioned before, we do have we see a reduction time in carry out those inspections that can be done remotely. So again, less exposure to to dangerous environments that we have there. So resources can be managed better. They can be allocated to other tasks.
Mm-hmm. Okay, thank you. So I would like to move to another aspect, which we have not touched so much for the moment. Maybe starting with you, Taylor. Which frameworks have you seen, or are you aware of that have supported, or maybe been an obstacle for the value sensitive development of your company? So I'm thinking about policies, regulations. Is there anything that has hindered your development? Is there anything that has fostered your development? Anything that is missing but would have helped to have? You said
Well,
at the end of your
as I said
sorry,
a
you
bit
said at the end
at the
of
end
your
of my presentation, our next project is
yeah.
to help the city to be able to build, let's say, a new neighborhood to evolve with respecting the legislation, because in France it's kind of very tough, and it's very difficult to know what you have the right to do or not. So yes, it is, for me, it's more an opportunity to be able to build something that make people understand something very complicated.
Okay, it's an opportunity for the
Yeah.
business project you're looking at. Okay, very good. Björn, you mentioned that you work on that ISO certification on climate gases. What's your view on that question? Any frameworks on policy regulatory level that are helping you or that are hindering you?
Yeah, so we have looked at ISO 14067, which is a EU regulation that was supposed to come for big manufacturers in EU, and we want to create a solution for smaller manufacturers to also meet those demands and to document the climate gases emitted during the production. But what we saw is that the problem is the data is not there. So it's the EU regulation for ISO 14067 is not possible at the moment because the life cycle inventory data is missing. So that's a big hurdle for us. So that's something we are looking into doing more research on. But in Norway, the hurdle is getting funding for risk funding for development and research. So we have applied for a lot of funding for this project, but yeah, we're still missing some funds. So that's one hurdle, but also we need to shed light on how much data is missing. Like if you buy a circuit board from China, you won't get any data from that provider on how that circuit board was being produced, and we need to be more open on that.
Okay, thank you. Lorenzo, what do you think about the policy regulatory framework? Is that anything that's impacting you?
Yes. Yeah, so I think indirectly, it's the ability of our clients to use equipment, specifically when we refer to drones. So various countries have a different regulation, and so they might be limited on how fast they can scale the operation with this equipment due to local regulation. Another point is probably about data security regulations. We see this also as an opportunity anyway to offer better solutions to our clients on that front. For inspection specifically, we also see a variety of requirements for reporting, and but then again, we see this as an opportunity, so we do offer customized reports following basically the guidelines that are relevant for that specific industry or country.
Okay, thank you very much. So very interesting to see that there can be both opportunities and obstacles from the regulatory and policy level. All right, I think we need to close the discussion round at this point, but I would like to give the floor to Charlotte for a quick wrap up and to let us know what's coming up next. Well, Charlotte, please.
Yes, I'm just going to share my screen again. Can you see my screen? Yes, okay, perfect. So thank you very much to each one of you. We had very interesting presentation. I would like to share some interesting point that I noted during the presentations and the answers also, that the points that were raised during the interactive discussion. So digital twins, so as it was said, it's like a kind of virtual models of something physical, which means that we don't need to be physically there also to monitor and plan our processes. It helps businesses and also municipalities, as it was said, so to plan, monitor, analyze system in real time. So it helps to gain insights and see where, for example, we can have some improvements that can be made, or even, as it was said, to plan the future. Digital twin can share data in real time across different teams on a shared platform. So it enhances collaboration, improve efficiency and reduce costs, and also it helps in better decision making. And as it was also mentioned, it can be applied to various industries. We heard about the manufacturing, the infrastructure, and also the urban planning. So now I'm going to go back on forging. So also to show you the upcoming activities that we will have. So this was, as I said earlier, our 4th webinar edition. We will have two other webinars, one on energy efficiency, beginning of March, and the last one on human-machine interaction. And here is a slide, as I said also at the beginning, in forging we aim to set up a forum with different backgrounds. So here I put the QR code on the right. So of course we will be very happy also to have you, so you can scan the QR codes and join us. And thank you very much for all of you, participants and speakers. And I hope to see you to our upcoming webinars. So thank you very much.
Thank you very much also from my side, Björn, Lorenzo, and Shadel. It was great having you. Have a good day. Thank you. Bye-bye.
Thank you.
Pleasure. Thank you very much.